All right, almost done. Number 24. We're asked to find these two limits and subtract them if possible. So the first thing that I notice is that this limit is going to infinity and this one's going to 2, so I cannot combine these. Actually, I'm going to have to do these two limits totally separately and then subtract my answers. All right, so let's look at the first part. All right, that's a end behavior, so we can look at the exponents. Well, the exponent in the numerator is the same as the exponent in the denominator, so we're going to take the ratio of the coefficients. The coefficient of x on top is 1, x on the bottom is 1. So that's 1 over 1, which equals 1. Right, so the first limit is just 1. Okay, now the second limit is going to give me some problems because if I plug in 2, I get 0 over 0. So it's indeterminate, so I'm going to have to do a little bit of work. So the number in question is 2, so I need to look at what happens before 2 and what happens after 2. So let's start with before 2, less than 2. Alright, if x is less than 2, then the numerator will be, or excuse me, the denominator will be negative inside the brackets, and therefore we're going to have to take the opposite. Alright. And then we have a kind of an interesting situation in the numerator because we have another absolute value. Well, the absolute value of 1.9 is still 1.9, 1.8 is still 1.8, so that doesn't really cause a problem until I hit something below 0. So this really only works from 0 to 2. If we go below 0, then we have another negative situation. But we don't need to worry about that because we're only interested in what happens at 2. So as long as we're between 0 and 2, x is still positive. All right. Now if x is greater than 2, all right, then the numerator and the denominator will both be positive and we don't have to worry about it, so they're just going to stay the same. All right, so if we simplify this, we get f of x equals -1 if x is between 0 and 2, and +1 if x is greater than 2. You can put the brackets if you like. Alright, so now here's the important part. Now I need to do my left and right limits. Alright, so the limit as x approaches 2 from the left is equal to -1, and the limit as x approaches 2 from the right is +1. Probably done this a million times by now. Since the limit from the left is not equal to the limit from the right, oops, I forgot my f of x, excuse me. Alright, therefore the limit does not exist. Alright, now you might think that's all well and grand, but we still haven't quite answered the question, which was, if you remember, this right here. Since the limit of the first one is 1, the limit of the second one does not exist. We cannot combine them because they are not going to the same limit. Therefore, the whole limit does not exist. So let's see. We can retype that real quick, or rewrite that. So